Now that we've introduced vector differentiation, the next step, of course, is to discuss vector integration. So let me start out with indefinite integration. So if r of t is a vector function, and I'm leaving some space to write out the component form of r, then we define the antiderivative of r. T is the set. So just as with ordinary antidifferentiation, there's going to be more than one, of all r of t with r prime, big R prime of t equals r of t. So if r of t is equal to f t I plus g t j plus h t k, then from the fact that differentiation is done component-wise, the indefinite integral, which we'll write still as this integral dt, this will be the indefinite integral of f dt I plus indefinite integral g of t dt j plus indefinite integral h of t dt k, and then plus c, a constant vector. So we don't need to put like a plus c1 plus c2 plus c3 in the indefinite integrals of f, g, and h, because we can just absorb those into a constant vector c. Okay, so let me do an example. So, for example, if we looked at the indefinite integral of cos ti minus e to the 2t j plus t squared k dt, then we just integrate this component by component. So this will be sine of ti minus 1/2 e to the 2t j plus 1/3 t cubed k, and then plus a constant vector. Or another example, let's say we took integral of sine of t I minus t to the 5 j plus 1 over t k dt. So here t is not 0. Now we would get negative cos t I minus 1 over 6 t to the 6 j plus ln of t k plus a constant vector again. Next, let's talk about definite integration. So if r of t is a vector function with components f, g, and h, and a and b are real numbers, so the bounds of our integration are still scalars, then the definite integral from a to b of r of t dt is defined to be just the integrals of, so the definite integrals of all the component functions times the appropriate vectors. So plus gt dt j plus integral ht dt k. So for example, if we took integral from 0 to pi of negative sine ti plus e to the t j minus 3t squared k dt, this would be cosine t pi 0 times I plus e to the t pi 0 j minus t cubed pi 0 k. And so this will be, this is negative 2I plus e to the pi minus 1 j minus pi cubed k. Or here's another example. Let's take integral from 2 to 3 of ti minus 1 over t j plus t cubed k dt. So this will be 1/2 t squared 3 2 times I minus ln of t 3 2 plus 1/4 t to the 4 3 2 j k. And then this will be, so 9 minus, it'll be 5 over 2I minus ln 2 over 3, or sorry, plus ln 2 over 3j. So here this is minus ln of 3 minus ln of 2 j, and then using log rules, that's the same thing, plus 1 over 4 is k of 3, 4 is 81, minus 16 is 65. Finally, here's an example of a physics application. So a hang glider's acceleration at time t, we're told, is given by a of t is negative 4 cos ti minus 4 sine ti plus 2tk. And we're told also that it took off, so time t equals 0, from position 5, 1, 0, and, or let me say, with velocity v0 equals I. And now we're asked to find the position and velocity as functions of t. So let me just erase the problem statement, but leave up the equation that we need. So make space. So we have initial condition 5, 1, 0, and initial velocity I. So our first step will be to integrate the acceleration function to get the velocity function. So v of t will be integral acceleration dt, and so that will give -4 sine of t I plus 4 cos t j plus t squared k plus a constant vector c. Now we're given that v of 0 is I, so we get I is equal to -4 sine of 0 is 0, is equal to 4j plus c. So c is equal to I minus 4j. So this already tells us the velocity at time t. Let me rewrite it up here. So the velocity at time t is given by 1 minus 4 sine ti plus 4 cos t minus 1 j plus t squared k. Okay, so then we need to, from there, we need to find the position at any given time, and any given point in time. So now the position will be r of t integral v of t. So now this will give t minus or plus 4 cos t I plus 4 sine t minus t times j plus 1/3 t cubed k plus, again, a constant c. So now we've got, now we'll have 5i plus j equals, so at time t equals 0, this will give 4i minus, sine of 0, 0, t is 0, plus c, like this. So then we get c is equal to I plus j. So the position at time t is given by t plus 4 cos t plus 1 I plus 4 sine t minus t plus 1 j plus 1/3 t cubed k.